Guys, how are you doing? Hope all is well with everybody, and hope things are going okay. Let's take a look at what we're going to be doing next, which is exponential and logarithmic functions. So basically, I had told you before that you can solve exponential functions by logarithms. So that's like the whole point. So let's take a look right here. So, for example, number one, okay, maybe the way that you would go about doing number one, let me get a different pen here, is just to say, okay, 9 to the 2x power equals 27 to the x minus 1 power. Now, one way you might just think about that and say, okay, wait a second here. 9 is, of course, right here going to be 3 to the second power, right? So we can say right here, that's 3 to the second, all to the 2x power, equals, and I know 27 happens to be 3 to the third power, right? So we'll say that's 3 to the third, all to the x minus 1 power, right? And then you could say, okay, let's simplify this right here. We know that 2 times 2x is 4x, so it's going to be 3 to the 4x equals, that's going to be right there, 3 to the, and then you would distribute, right? 3 times x is 3x, and 3 times negative 1 is negative 3. And then you would say, oh, okay, right here, I have the same base. We have 3 here, we have 3 here. So, since the base is the same, and the entire, both exponential functions are the same, right here, we could just go equate the exponents. We would just say 4x equals 3x minus 3, right? And then going ahead and to solve right here, I'll just go ahead and, I'll go ahead and subtract 3x on both sides. 4x minus 3x is 1x equals negative 3. So I have my answer right there, x equals negative 3. All right, and for these, you are supposed to go and do a check. I know that kind of gets, tedious after a while. I'll tell you, actually, I'll make it aware where it's completely necessary. But for right now, we can just see right here that's going to be 4 times x is 4 times negative 3, so that gives me 3 to the negative 12th equals 3 to the 3 times negative 3 is negative 9, minus 3 is also negative 12. So you're good right here, okay? All right, so that's how you would do number one if you're not using logs. Now, sometimes it doesn't work out so nicely, right? So let's look at one that doesn't work out so nicely. We have 4 to the x power equals 11, right? All right, so let's take a look right here. 4 to the x power equals 11, right? All right, so why is it that, I can't go and just actually equate the bases right here like I did before, right? Because 4, all right, that's 2 to the second. 11 is nothing. It's 11 to the first, and that's it, right? Okay, no problem. So what will we do here? Let's take a look here. All right, so what I have to do here is something a little bit different. What I have to do here is I have to take the log of both sides. I can do this. I can take the log of the same base of both sides. Now, right here, you're either going to be going and taking the log of both sides or the natural log of both sides for these exponential equations. In this, if you have an e, then you want to take the natural log of both sides. If it's just like regular old exponents without e, then you'll just take the log of both sides. And that means, of course, log base 10 of both sides. So I'm going to go ahead, I'll take right here the log base 10 of 4 to the x power equals the log base 10 of 11. Okay? Cool. Now, right here, what do I do now? Well, what we're going to do is we're going to use our properties of logarithms to know that, remember, if I have an exponent right there, I move it right to the front. So that's going to give me x times log of 4 equals log of 11. okay? And then next right here, what am I going to do? I'm going to solve for x right there. So I'm going to divide both sides by log of 4. All right, so now I will have to use my calculator. X equals the log of 11 over the log of 4, okay? So let's do it. Go ahead and do that. So we're going to go ahead and say right here, it's going to be, let's see, the log of 11, close up the parenthesis, over the log of 4, close up the parenthesis. And that gives me round to 3 decimals is fine, 1.7297. Okay, so that rounds up to 1.730, right? That'll give me that x equals 1.730, all right? I'll say, you know, I think 3 decimals is best, but even if you rounded to 2 decimals, that would be okay too. All right, so that's what you do in most cases, right? Because a lot of times the bases, you're not able to go and make a exponent with the same base, right? What I'm trying to say is like 4 and 11, I couldn't make that the same base. So a lot of times you have to do what I just did right there. Let's look at another example like that. Right here we have 2 to the x equals 5, right? Okay, no problem. So we're going to look at number 4 right here. 2 to the x power equals 5. Okay? So let's take a look. So what am I going to do right here? First thing I need to do is, actually first thing what you want to do, I should have said this before, is for your steps right here, is you want to actually basically, you want to isolate x as much as possible. So that's step 1 right there. Now in this case, in the previous example case, x was already isolated, but you can see from, for example, this problem right here. All right, we'll do that one next. You have to do a little bit more, right, to isolate x as much as possible. And then your second step is, once you have that x, basically, once x is in the exponent, it's isolated as much as possible, then you would just take the log of both sides. And of course, right here, last step is just to solve, okay? So that's right here. All right, so x is already isolated, it's already done. So we're going to go ahead and take the log of both sides. Log of 2 to the x power equals log of 5, okay? And then next right here, that x right there, okay? Now that we have a log of both sides, I can take that x and move it right into the front. That's my properties of logarithms, right? That's called the power property, if you remember. And we move that x right to the front. Okay, and that still equals log of 5. Nothing changed there, right? And then we're just going to go ahead and solve for that x right there. So I'm going to go ahead and divide by log of 2. No problem. Okay, so this is right here. That's gone. So I have x equals log of 5 over log of 2. Okay? So let's get our trusty, dusty calculator out. So we have log of 5 over log of 2. So we just get log of 5, close it up, divided by log of 2, close it up. And we are good. And to get 2.321, that's going to round up. I mean, that's going to go round up, right? If it's 3 decimals, 2.322. All right. There we go. Okay. So very good. Let's look at number 6 now, because that's in that one you will have to isolate x first. So let's do that one. Plus it's an e, and I wanted to show one with an e. So this is actually perfect here. 4 times e to the negative 0.3x minus 7 equals 13. Okay. So right here. Negative 0.3x minus 7. Oh, I'm sorry. My fault. Minus 7 equals 13. There we go. Okay, perfect. So right here, and this is number 6 on the guided practice up there, right? For those people keeping tabs. Okay, let's do it. All right, so we'll start out right here. Okay, so right here, remember my first step right here, I have to isolate x as much as possible. All right, so right here, there's my x right there. I'm going to isolate that. So first step, I'm going to go ahead and add 7 to both sides. 4 times e to the negative 0.3x equals 13 plus 7 is 20, right? All right, and then right here, I'm going to go ahead and still have to, I'm going to solve for x as much as possible. So I want to get rid of that 4. I'm going to divide by 4 on both sides. So that gives me e to the negative 0.3x equals 20 over 4 is, of course, just 5. Okay. All right. So now that the x is isolated as much as possible, it's in the exponent, right? I'm going to go ahead and take right here, I'm going to take the natural log of both sides. Now, why did I choose natural log instead of just the regular log? Well, because we have e right here, so it makes life easier. Since we have e, we want to choose natural log. So watch what happens. ln of this side and ln of this side, okay? All right, so now what do I do? Okay, so next right here, I'm going to use my properties of exponents, right? I have negative ln of e to the negative 0.3x equals ln of 5. And I'm going to go and take that power and put it right there in front. So that'll be negative 0.3x times ln of e equals ln of 5. Okay? Very good. Okay, and next I'm going to go ahead and solve for x. But be smart about this. Wait a second. The ln of e. What is that? Wait a second here. That means that, remember, ln, the base is e, so you're saying e to the something power equals e. Well, that's going to be to the first power. So this is just going to be, ln of e is just going to be 1, so we can just cancel it right out, right? It's going to be 1. So we have now negative 0.3x equals ln of 5, okay? Makes life much easier. And now I'm just going to go and continue to solve for x, divide by negative 0.3 on both sides. Gone. So I have right here, ln of 5 equals negative 0.3. Let's see here. So let me go and do that on the calculator. So we have right here what? ln of 5, right? So that's going to be the natural log of 5. Sorry, my computer's being a little slow. Okay, and we're going to divide that by right here, negative 0.3. All right, and we have negative 5.365 if I'm rounding, negative 5.365. Okay. And that is it. We are good to go. All right. Yeah, so these right here, you're just going to go and solve, basically, and you'll be ready to go. I'm just going to give just some of these right here. Not everything, but I will give some of these as the next assignment. But first thing is just to watch this video, of course. All right, guys, that's enough examples for right now, I think, and we can do more later. This video is already long enough. Have a great day. See you.